Alright, this is lesson 83 for advanced math, and it is simple probability with a couple of different examples. And we're going to start with our definition for probability. Probability is a ratio that's made up of the number of desired outcomes divided by the number of possible outcomes. So, however many possible outcomes, that's going to be our denominator. How many outcomes we want, our desired outcomes, is going to be our numerator. So 1 is our flipping of a coin. On a coin there's 2 possibilities. It's either going to land on heads or it's going to land on tails. So the denominator of our probability is going to always be 2. Now, whether we want it to land on heads or tails, our desired outcome is going to be our numerator. So the probability that if I flip a coin and it lands on heads is 1 out of 2. I have one desired outcome, which is heads, out of 2 possible outcomes, that being heads or tails. Now, if I flip the coin multiple times, I can then calculate the probability of a certain outcome, and these are independent events. So the first time I flip the coin, it's going to land on either heads or tails, and that is a 1/2 probability. If my first flip is a heads, and I flip it a second time, it could land on heads or it could land on tails. If my third flip, I could land on heads or I could land on tails. So this is my first flip, this is my second, this is my third. If on the first one it lands on tails and then I flip it a second time, it's going to land on heads or tails. And then the third time, it's going to land on heads or tails. So you can see from my chart here, every time I flip it, it's going to be heads or tails. So the probability of the first flip is 1/2. The probability of the second flip is 1/2. The probability of the third flip is 1/2, So the probability that I flip it 3 times and it lands on heads every time is 1/8. And we can see it in the diagram here because this is all heads. This is heads and tails. This one is head, tail, head. This one is head, tail, tail. This one's tail, head, head. Tail, head, tail. Tail, tail, head. Tail, tail, tail. I've got 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes flipping a coin 3 times. I've got 8 possible outcomes. The one that I am looking for is where heads shows up every time, and that's only one of those possible. So the probability is the number of desired outcomes over the number of possible outcomes. Now, this is with the coin toss, and we could keep going. We could do a fourth flip, we could do a fifth flip, and for every flip, though, the probability is the same because it doesn't matter what we got the first time. When we flip it the second time, he is independent of that first flip, so it's still 1/2. So the probabilities are all put together. So if I want to do a probability of 5 tails in a row, that's going to be 1/2 for the first flip, 1/2 for the second, 1/2 for the third, 1/2 for the fourth, 1/2 for the fifth, and that's going to be 1/32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now, your roll of the dice, remember, you have 6 sides to the dice. So the probability, let's say that I'm going to roll a 5 on my dice. Well, the desired outcome is 1. I just want a 5. And the possible outcome is 6. Because there's a 1, 2, 3, 4, 5, and 6 on the dice. So that's the probability with 1. Now with 2, this is 1 dice. With 2 die, if I wanted to say what's the probability, I'm going to roll a 7. We're going to do a picture here to make it clear. I have 1 dice that has 6 sides, and I have a second dice that has 6 sides. So when I roll the 2 dice, if they both land on 1, then my sum is 2. If they both land on 2, then my sum is 4. So you can see we can fill this chart in. If one of them's a 1 and one of them's a 2, then my sum is 3. 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. A 3 and a 1 gives me a 4. A 4 and a 1 gives me 5. 6, 7. A 3 and a 2 gives me 5, 6, 7, 8. A 3 and a 3 gives me 6, 7, 8, 9. Four and a 8, 9, 10, 7, nope, 9, 10, 11, 10, 11, 12. So I have 2 dice. If they both land on 6, my total is 12. Well, this is, I want the probability I'm going to land on 7. Well, my denominator, remember, is the possible outcomes. So I've got 6 here and 6 here. I have 36 possible outcomes. You can count them there if you want to. But it's 6 rows, 6 columns. 6 times 6 is 36. Out of those 36, the ones I'm looking for are the ones where they add up to 7. And I actually have 6 of those. 1, 2, 3, 4, 5, 6. So there's 6 possible outcomes out of the 36. So that means my probability is 1 out of 6, which is a pretty good probability. You'll see that's the most common. There is no other sum that appears more often than the 7. Now, if I roll the dice, and then I roll the 2 dice again, like with the pennies. Those are independent outcomes. So I roll the dice. What's the probability that I'm going to roll and get a 7 and roll again and get a 7? So that's going to be the probability of a 7 and then another 7. It's going to be 1/6 times 1/6, which is 1/36. Probability that I will roll a 7 and then on the second roll, roll a 7 again. All right, thank you.